Thanks for joining me. This is a standard operating procedure, the Cafe Tele live broadcast, here to teach you tips, tricks, techniques, and tactics to help you love a career in telecoms. Today, we're working on telecom modeling, and this is, I think this is our fourth episode of telecom modeling. We've been slowly building up some of the skills and the different approaches to modeling. Last week, we tried to do a live comparison between it was a completely made up example, but just to illustrate some of the techniques we use with modeling. Excuse me, we compared the cost of a long-term lease for a 10 gigabit lease line, 10 gigabit per second circuit, and versus a sequence of short-term leases back to back. And we worked through all the techniques there. I guess I can turn this off now. There we go. Hey. So today we're going to start from, in English you'd say start from scratch, start from absolutely nothing with a blank workbook, and continue to build up a complete model. I don't have a specific example in mind like the lease line circuit, but these techniques will do you fine for whatever you're trying to do. And if you have two choices, you would simply run this twice, once for each choice, and then compare the two. Yeah. Okay, so let's do that. I'm going to share my screen to get the, share the entire screen. To get the workbook on screen, let's share that. And there's my workbook. So it's not completely from scratch. I started out just formatting this table. This is where I'm going to put all our parameters and variables to use during the inside the model. And I'll just be honest with you, I always practice this in advance so I don't lead you guys astray. So here's the one I started, and here's the values that we're gonna put into today's model. So what you see here is, it looks like really three values. And I'll just start by defining, this is the date that the model is going to begin, yeah? Start date. And I would suggest for your models, always have a default value and give the user an easy opportunity to override your default. Let me show you what I mean. So let's say March 1st of this year, that's just a few weeks from now. And if I want to have a defined value, if the user overrides that, say April 1st, well, that didn't work out so good. There's my override, yeah. And I need to put a formula here that will select the override if it's there, and if it's not there, select the default. And that's just an if statement. Here's my if statement. So if the default is present, my used column shows the default, let me say that again. If a user-defined value is present, it will display the user-defined value. If there's no user-defined value, it shows the default. So this way, you've always got, your model will work right out of the gate, even if the user doesn't input any values. Okay, so that's a tip right there, is always provide the user-defined opportunity and a default. Use the default if there's no user-defined value. Use the user-defined value if it's present. Okay, so but actually to get started, that's how this whole table is going to work. Is this column is all going to be trying to choose between the default value and the user default value. Sorry, the user inputted value. Okay, Najib, it looks like it's just you today. So if you have any questions, please just type them into chat, and I'll do my best to get to you. And sorry, go back and forth to my notes here. Where's my notes? There we go. Let's see. Yeah. So what I'm going to start by, we use this all the time, is just a sequential count of intervals inside your model. And let me not goof around. I'll just do it. Let's say, well, I'm just going to start with columns, and we'll start here with L2, and I'm going to anchor that. I use the shortcut function F4 to anchor. And all anchor does is, if I use the fill handle, anchor keeps the first cell in the range the same, and by using the fill handle, it will increment the second half of the range. So can't see that very good, but I'm going to fill this, and you'll see it just fills across 1, 2, 3, 4, 5. It's just a sequential count. The columns function returns the count of the number of columns in its argument. And because the argument is a range, right, it keeps growing. So out here, it starts with the anchored L2. I know you can't see that very well, but and it goes to P2. And if I pull right, it'll just keep incrementing. If I switch to full screen, it doesn't get any larger. The formula text doesn't get any larger, and I can't see your chat messages. I can do that, and I can zoom in, and I can also do this. Obetta, now you can see there's the columns function. Yeah, it makes the model a little hard to read, but for training purposes, that makes perfect sense. So that's just a sequential count. And I would always suggest, take your count, always make your model bigger than you think, meaning I'm going to run this out to the right here. And you can see I'm out to column FA. There's 150, almost 150. There's 150, right? Always make it bigger than you expect, because we'll cover something a little later that allows you to select how much of it you're actually going to use. So make it bigger than you need, and that way you can define a parameter that you can set how many months. In this case, it's a monthly model. You can use that parameter to define how many of the months are there. By going out 150, that's, what is that? That's 6, 10. Well, that's more than 10 years, right? That's almost 15, 12 years, 13 years. For telecom, that's a long time. Oh, one more thing. Since we're navigating all the way, I'll go exactly to 150 just because I'm like that. But then I would always, I'm going to fill down here. Makes it easy to jump around. That's all this does. I use the keyboard shortcuts to navigate. So I can do if you're on Windows, it's control left arrow, and it jumps me all the way back to the end of this range, essentially. If you've got data, so there you see it just went to the beginning. Now, if I do it again, this is the control to the right arrow. It'll jump all the way to that last column of X's I did, column what, FF, yeah? So it's a very fast way to navigate a very large workbook, worksheet. And if you have a lot of rows, you can use the control up and down arrow, works the same way. Okay. Okay, so the next thing I want to do is we're going to have several cycles inside of this model. So to do cycles, there's two approaches. This is just the sequence. We'll do a cycle, and this is the quotient. All we're going to do is divide one number by another number. So we're going to divide this number. It won't work because it's not a formula. L2 by, why is that looking weird? By whatever our cycle is. I'll have to wait and do this because we don't have those parameters set up yet. So let's do our date. This is the start date for the model. And that's going to be, here is the value we're going to use, right? So we're going to use the date function. And let me type in the formula, and then I'll copy and paste it so it's easier to see. It's just the date function. And then take the year of this start date. Normally, I would tell you to give it named ranges, but that'll take a little extra time. That's going to be better. So here's my start date. Now it's a named range, so my start date here all I'm doing is putting in the value. I gave this cell here a name. I made it a named range, so it makes the formula really easy to read. Use the shortcut, the function F3, and let's copy that down and remove the equal sign so you can see the formula. There's the formula. It's just the date function, which takes 3 arguments, a year, a month, and a day. And I get each of those values from the start date. And let's... And for the model, I would tend, usually the day isn't going to matter if it's a 3-year model, which is fairly typical. The day doesn't matter. So let's pick a month and year. So there's our model. And like I said, extend this out to the equal sign, and then the shortcut to fill right is just Control R. So what did I do wrong? Well, I can't just use this. I need to add the increment to my month. So right here in the month, I'm going to add the counting month. One more thing is I think it works out better if you start with 0. So I'm just going to subtract 1, and then again, I'll fill right. And then now I need to add this value. So right there, plus L2. And now when I fill right, it increments. So it goes out to August of 33. That's 12 years. That's pretty good, yeah. And so you can see it easily. I'll put it, we're just going to add that month, this row 2. And that's how it worked. You can see the formula right there. And as you fill right, you're going to add L2, M2, N2, O2. So you keep adding 1 to every month. Okay, I got to check my notes here. Better save. So we got the interval, we got the date. Okay, let's start with a one-time cost. Now, this would be like a setup fee or a configuration fee or whatever the vendor or the services provider is going to charge you. So it's just a one-time cost. Make another. And typically that's going to be at the beginning. So we're going to start with our one-time cost. And what did I use? One time I said $10,000. Mostly these will all be the same. I'm just going to fill it down. Oh, yeah. and that's actually a dollar value, and I can still overwrite it. Great. Okay, I also have a one-time start interval. Now, typically the one-time cost would start at the beginning, but I want to give you the option. At the beginning would be 0 because we started our count with 0, and that is not a dollar sign amount. And it's still 0 here because a 0 it's formatted as a 0. Yeah. So what I want to do here is, just so we have we can see, I'm going to put a value there so that we can see something. So what I want here is I want that one-time cost to trigger when this value matches our sequence. That's just an if function, right? N equals so I keep using shortcuts. I'm not trying to confuse you. So you can see there is my one-time cost. If I delete that, the one-time cost comes at the very first month. And let me give you that so you can see it better. Now, since I'm filling down, these aren't always going to look right. Right? So L3 would actually be L2. So it's just an if test. When the value in this row matches my start interval, it's going to trigger that cost. Okay? And you can see it'll jump around based on what I put here. That's just if something should happen, in some case, maybe you got a contract, maybe your procurement department says, hey, we're not going to pay that until the third month, or, until the hardware is installed, or until the hardware's on the dock, or whatever. It just gives you a little more flexibility. Okay, so that's the one-time cost. And then now we have a monthly recurring cost. So let's do that. MRC, right? Oops. Have to do it in the right place. Okay, here's our monthly recurring cost. And that's just basically our monthly recurring cost. And that's pretty easy to do. And the value here, let's say, is 2,500. And I can overwrite that like always. Super. So really, this is pretty simple, right? It's just this value. And you can see that I used the named range there, so it couldn't get much simpler. MRC, right? And let's format that as a number. I'll have to come back and fill this out to the right. I'm just trying to make it easy to see on screen here. Okay, so that's the monthly recurring cost. Now, we should also, sometimes for a longer contract, you might have a built-in discount. Last week during the comparison of lease line costs, there was a discount that we assumed every time you renewed the lease, the cost of bandwidth declined a little bit, right? That's just the technology. If I get a 10 meg circuit right now, a 10 gig circuit right now, in 12 months, it would cost me less to get the same 10 gig circuit. So that's the discount you want to build in. For some contracts, there might be the opposite of a discount, an increase, or what I would call an escalation. So let's put that, I'm just going to call it an escalation. A discount would be a negative value, right? So I'm going to check my notes here. Yeah. So this is the escalation percent and the escalation cycle. And what I mean by cycle is how often does that escalation take effect? Is it every 3 months? Is it every 12 months? Is it 18 months? Well, it's variable. We can set that. So let's say the default is 12. So we can see it on screen here. I'm going to say it's 3. This is not a dollar value. It's just an integer. And the escalation percentage, let's say it's 5%. Okay. Escalation cost. I got to check my notes because this is a little bit complicated. This is just math. It's just algebra. And if I was in the office, I'd grab my engineering notepad and do it with a pencil and paper because that's how it makes sense to me. F9, yeah. So it's the monthly recurring cost times the power 1 plus the, okay. Escalation percentage. Oh, wrong one. Here's escalation percentage. And I do encourage you to name your ranges because as you can see, it makes the formulas much easier to read. Right here, this is just MRC, right? This will be a good example because it's a fairly complex formula. Using named ranges makes it much easier to read what you're doing. So the escalation cost is just going to be the monthly recurring cost. I prefer the month so you can read it, is the MRC times the power function. 1 plus the escalation cost, escalation percentage. And here's where I got to back up. This would be how to say that right now, just so I don't lose what I've typed. But let's call this the escalation cycle. So here's where escalation cycle. So I've said it's 3 months, yeah? It's 3 months. The way we implement that is every time 3 months goes by, we're in a new cycle, right? So right now, if we just divide row 2, divide these by 3 or by the escalation cycle, that's the quotient function. Basic algebra. Basic algebra. So don't be intimidated, but quotient is what number and what do we divide it by? And this is going to be, I'm going to use the shortcut function F3 to get the escalation cycle. So there you can see it's actually L2. I can help that by doing better. So now when I fill this to the right, you can see every time it's a perfect multiple of the escalation cycle, it will count. That's the quotient. It's just, quotient is just whatever the number is, it's the integer number of times that the divisor or the escalation cycle will fit in. So I can use that here. Instead of 1, it's so this is a cost. And let me fill it down so you can see the formula. There you go. So see what I mean about being easy to read? The escalation cost is just the monthly recurring cost times the power function. And the power function, it's compounding. Since my cycle is 3 months, every 3 months, I'll compound or multiply it again. So, but this is not quite right. Since I've already got the MRC and I'm going to add these up later, I should subtract away the base MRC so that this should be only the added cost of escalation. So that's going to be the MRC minus that should be here. So all I did was, this is simply the escalation cost now. So now on the escalation cycle, the cost of the MRC is going to increase by $158. And then when the cycle changes again out here in R, that escalation percentage gets applied again. Oh, clear? Is that okay? So that's just if there, and you know, if it happened like we did last week with the cost of bandwidth, what if it declines? Did I type my formula in? Well, sure, why not? Makes it negative. So this works whether the escalation percentage is positive or negative. Easier to look at if it's positive. So I'm going to, this in the model, what this means is every so often the cost of this product or service will increase. It's a built-in cost increase, a cost of living adjustment or something like that. Okay. And now this would be a more practical. Make it 12 and you can see up here, the escalation cycle doesn't change until we get to we change. That's the 13th month actually, right? So you see there's no added on cost until we get to that first escalation, and then it goes up every 12 months. It's like magic. That's the escalation. Let's see. What if there is a non-monthly recurring cost? So what I mean by that is, just like with the escalation cycle, right now, every 12 months, there's this automatic price increase. What if there was also like a maintenance charge or annual support, something like that, right? But why tie it to the escalation cycle? So let's do the non-monthly recurring cost. This will be easy because we just did it. It's the exact same thing, but we're giving it its own cycle. maybe you'll never need that, but the point, one of the key features of a model is you have all these variables that you can change over here. Yeah, you have all these variables that the user can define here in the model, and the value will change, but you didn't have to change the model. Once you've got the basic model, it should never need to be edited. And you certainly wouldn't want to edit your model. I mean, change the formulas while you're presenting it to your boss or to anybody else. So that's why you build in all this flexibility and, you know, the capability, so that when you start showing it to someone and working with someone, everything they need is right in there. You don't have to change the model itself. Ideally, I don't remember were you here for the last one, but when you're doing a comparison, really all you do is, you know, you don't even have to show the model at all. You can show the values, you know, each different, if you're comparing two different approaches, you could put the values of those two approaches very close to your parameters. And then just, you know, as you change the parameters, the model right there in the same location, you can see which one is going to be a better deal, which one works out better for your company. You don't really have to look at each, you know, nobody wants to go through this part of your model. Nobody wants to do that. Somebody will, just to, you know, we've all had that kind of boss who kind of likes it when you're wrong. You know, I hate to say that. But there will be people probably who really want to dig into your model and see what you did, right? So if you've done it really well, you can just change the values. You don't have to edit the formulas in your model when you're demoing it or presenting it, or you know, making your own recommendation based upon the model. Okay, let's see. So there's the non-monthly recurring cost. I'm going to call that NMRC. And like I said, this is like a maintenance fee or an annual support, something like that. Who knows what it'll be. So this would be the NMRC cycle. If you wanted to get really clever, I'll leave this as an exercise for you. You could apply an escalation percentage to this non-monthly recurring cost. I mean, we've already done it, right? Here's the power function, right? But let's see. The non-monthly recurring cost, I don't know, once a year, $1,000, $1,250. And that should be a dollar value. And the cycle, well, let's just make it different. I'm going to say the default's 12. Ooh, that doesn't look good. Let's make it, I said 12. And let's put in again, so we can see it well. So this is the NMRC cost. And I need a different cycle. So this is the NMRC cycle. Oh, it's well, let's do it like that then. Heck. Looks good, yeah. Let's see. Oh, NMRC cycle is just, again, this quotient. And this is the NMRC cycle. So it's, and the number is, and I'll anchor that so I don't have to change it when I drag it. And then it's function F3 shortcut, the NMRC cycle. And fill it down so you can see it. There's your quotient again. And it should behave just like this one when the value of this one is an even multiple of your cycle, it'll increment. Okay. Okay, so just like with here, I can just copy that. I can't exactly though. This is my non-monthly recurring cost. And so here it will be oh, sorry. This is the simpler one. I'm so sorry. Sorry to confuse. I've said we'll leave it up to you to do an escalation. I'm just going to check if someone trying to contact me. Okay, I see your question. The previous webinar was it was an example of a model of two approaches. The first approach was to lease a 10 gigabit per second circuit with a single lease for the entire duration of the project, let's say 10 years. Day one, you signed a lease that was 10 years long. And I put together a model that covered that. What were the costs associated with a single lease, 10 years? Compare that to another approach, the same 10 gigabit circuit, but instead of one 10-year lease, you could have variable length leases that ran back to back. So simplest case is a 10-year model. What if you had 10 one-year leases back to back, right? So as soon as one lease ended, the next lease started. But in that model, if you had this escalation percentage, every time you renewed the lease, the cost of the bandwidth would probably have declined just because the cost of bandwidth goes down over time. A 10 gigabit circuit today would cost a lot less 12 months from now or 18 months from now. So the model I built last week was those two cases. Compare the cost of those two cases. What's the cost of a single 10-year lease versus the cost of versus the cost of multiple leases running back to back or consecutively, sequentially. Add that up and compare the cost of the two approaches. Each one is a different approach, right? So that's what we did last week. Yeah. So if we were going to try that here, I would use this same model. I would set it up for a single 10-year lease, and then I would just copy it and repeat it for the back-to-back increasing leases, the back-to-back sequential leases. Yeah. Completely artificial example, but just one that's happened to me before, and I wanted to use something from Telecom so that it would make it would be relevant or make sense for you guys. Yeah. Okay. So that's what we did. Hope that helps a little bit. Back to where I am now, though, this non-monthly recurring cost, I gave the example of like an annual maintenance fee or a support fee or something like that. But I don't want to hard code into my model that it's every 12 months. So I'm doing this a little bit like the escalation cost, but there's no escalation percentage. It's simply a fee. So that's just an if statement, right? Equals if, here's my quotient. I'll do this one first. If my cycle is 4 equals this cycle value up here, and there we go, show the fee. Yeah. I'm getting a little confused here. This is the, didn't I name that? I thought I named this. Maybe not. Oh, I see what happened. Great. All right, let's try that again. Here's my if function, and it's going to be if my cycle is equal to quotient display the NMRC, otherwise 0. Is that right? I don't think I did this. I didn't get around to this. Yeah, I didn't get around to this, so I got to think a little bit here. I'm leading you astray, and I apologize for that. You can see my model, see my formula here. What I want, it's a little bit different. See, it is different. Here's I used the quotient function, this one here, but that's appropriate in this example where I'm compounding, because I can use this value when it's 0. The power function is just 1, right? So it works out good. But actually what I want for the NMRC cycle is every time this changes, so right here, it changed from 0 to 1. Here it changed from 1 to 2, right? Every time it changes, I want to impose a fee. And that's not the quotient, that's going to be modulus. The modulus operator is really what's left over after you do division. So I'll show you what I mean. It's mod, and I'm still dividing this up here. It's the only thing I have to change. You can see it just cycles, right? And every time the sequential count is a perfect multiple of the cycle, it throws a 0, shows a 0, right? So now, sorry, let me finish that. It's just the modulus function. Modulus is if quotient is the integer number of times that the divisor goes into the number, the numerator. Modulus is what's left over when you divide the numerator by the denominator, by that cycle time. So every time this is a 0, with one exception. Yeah. Other way around. Here's the case where when this value is a 0, I want to impose the charge. But you can see that's not quite, well, that didn't work out right. If that. I overwrite my, yeah. That's not going to quite do it. Okay, let's talk about that one. I still don't have it right. This is why I practice. If I don't practice, I don't get it right. Much better. Okay, let's see what's going on here. I'll copy it so you can see it, read it easily. Okay. All I'm doing is I'm using an if, and the if has this is the basic arguments for there's three arguments for an if statement, right? First argument is an expression, and the if function executes that expression. If the result is true, it'll do the second argument. If the result of the expression is false, it does the third argument, right? So Excel also treats a 0 as a false. And anything that's not 0, that's a true. I'll make sure I understand that, because I always say it wrong. It's a little counterintuitive. The logic isn't great. Oh, thank you. That's a nice thing to say. Okay. Did someone else join us? I see there's 2 people in the webinar now. Okay, so false to a 0. Yeah, so the way to read the if statement is the expression L7, it's a 0. That's false. Excel treats numbers. A 0 is false. Any other number is true. So when this is a 0, it's going to impose the cost, right? So when our if statement is true, it shows a 0. The result is 0, right? The expression is true. Let's read the if statement. If the expression is true, display a 0. If the expression is false, display NMRC, right? Okay, that's what we've got here. But my guess is you wouldn't have this one-time non-monthly recurring cost on the very first one. That's what this is. That's your non-monthly, that's your startup cost. So there's probably one case where you don't have this, and that's if the sequence is 0, better. All I did, let me fill it down so you can read it, is I added another if. If L2, right, again, it's a 0. So for the first column, we do the false case. The true case is this second if statement. The false case is 0. So that only applies in the very first column. For every other column to the right, it's going to do the true case, which is what we've got here. And I'm going to run that out. And that should be a number. Okay. Let's see. So how are we doing? We've got 10 minutes left. I think we've got time. There's one more thing we want to do. Well, 2 more things. First thing is we need to total this up. So this is the subtotal. And that's going to be, we're going to do the one-time cost plus the monthly recurring cost plus any oh, oops. Just adding these up is all. So all I did was add up the one-time cost, the monthly return cost, the escalation cost, and the non-monthly recurring cost. I think that's everything, yeah? And that should be a subtotal, so let's give it a border. And it does show as a number, yes. And let's go out, extend it to the right. We can see mostly, right? It just adds it up. Oh, I have to extend this out as well, and this one, and probably this one as well. Nope, he didn't like that. I got to do them one by one, I guess. All I'm doing is extending these formulas out through the whole model. That's all. And I'm using the control right arrow and fill right, there's fill right, to add the value. Okay, so now we have the subtotal here, right? So you can see you add up for 149 months, the value here is $825,000. But the last thing, anytime you want to calculate the value of something going forward in time, you use the net present value function. And the net present value that's called a range. Let's do a range. I thought I left that off of there. I'm just showing you the formula. So it's a discount rate and a range. The discount rate is, people will often call it the cost of money. And let's build that in here. It's just, the finance people will tell you that $1 today is worth more than $1 tomorrow. So although it's $3,150 this month, the $3,150 we'll pay in the future next month, it's not worth as much to us today. The NPV function is how you quantify that discount over time. Into the future, those expenses, when you look at them today, they're not as important. They're a lower value today than they will be in a month. $1 today is worth more than $1 tomorrow. And that's what NPV calculates. So I don't want to put it in the same column because it's not the same. So what I need is that discount rate, the cost of money. And typically this time, you know, with the way the economy is now, I'd use 6%. And as always, let's give an override possibility. And but the discount rate, this is a monthly model. So if our discount rate annual is 6 or 10%, we have to divide that by 12. Okay? Don't forget that, because it'll make you look, after this great model and knowing to use the NPV, if you forget to divide by the number of months in a year for an annual rate, you'll look dumb. So let's not do that. And then it's a range. And the range is just these expenses. There's my NPV. And see what happens when I eliminate the default. It goes back to 6%. So it raises the cost a lot. Like I said, $1 today is worth more than $1 tomorrow. So here's what the value of the whole project is with a 6% discount rate. If I use a 10% discount rate, the project is less because those future costs are worth less to me today. Okay? But there's one more thing we need to do. I went out 150 months. How long is this project? Well, fairly typically, a lot of your financial evaluations will be 36 months. Look over 36 months and that's enough. So what's the term? And here, I should say, that would be in so my term of project is months, so typically it'd be 36. So how do I get 36 into here? Well, if I do this, oops. Take away the equal sign so you can read it. It's NPV, 2 arguments. The discount rate is the first argument. The discount rate per interval in our model. So it's a month at a time interval. So we take the discount rate divided by 12. And then the range where we add up all these things. But I want to be able to just calculate for how do I build in 36 months. So I want to return a range. And here's the number, right? I want this range out here to be 36 months. Well, if you want to return a range, use the offset function. Remember our dynamic named ranges uses offset. If you want to do a rolling average, like a 3-day average or a 7-day average, offset's great for that. So let's change this. And let's just do it here. It's not perfect, but it will help you see a little bit. So I'm going to anchor it here. And then no row offset, no column offset. The height in rows, it's the same as the starting point. So I'm just going to skip it. The number of columns in my model, that's here. So this is a new feature. You can see, though, it'll run out here to 36. It's actually 35, right? Yeah. So I'm going to make a couple of changes real quick. I want to use this offset function, but 36 columns. Oh, yeah. That's why. So it is 36. I started here. I was confused. Why did I get out of only the column labeled 34? It should be the column labeled 35 because we start with 0 right here, right? But I started one column to the left, so that's my mistake. What we're going to do, though, is, this is the discount rate. And this is I'm just going to call this term. And let's put that in here so it's a little easier to read. I can put it in here too. Term. And that is a little bit easier to read. And it's a recent change. I'm using a Mac, an Apple computer, and all the Microsoft Office applications are horribly broken on Apple. They're barely usable. This is a new thing where it shows, I just put in this and it automatically filled out the whole 36 months. I don't think it does that on Windows, but this is what we want. So here it's going to be this offset function. There's my discount rate, discount percentage, and then my range is going to be the offset function. Oh, 32, yes. Okay. So now, I mean, if I do it for 1 month, use my override, it's about the same, right? So that tells me I'm probably close. If I do it for 2 months, right? So it's these two, 18.3, but it's discounted a little bit. Remember, a dollar today is worth more than a dollar tomorrow. So I think I've got it right now. So if this is the value of this is the net present value of this project over 36 months. If I just go out 36 months, row 2, I'll take it out to 35. Yeah. And 166,165, 165. But future months are discounted. So that's the cost. That seems plausible. So there's the value of this model as defined. And here I can change every one of these values. I can get a different result depending on what makes the most sense for my situation, for my business, for the mobile operator, the operator I work for. And I don't have to tweak the model. I just do this. What do you think? Questions? Questions? If you're on my mailing list, I usually send out a short email in advance of these, when I go live. If you're on that list, you can also download this workbook. I'll post it here in a few. Well, I'll also download this video, the recording of this video, and post that as well. There you go. Here's that link. If you click that go live link, I'll send you an email reminder before I go live, before these live broadcasts. And I will also, after the recording, after the broadcast, I'll post a recording to our YouTube channel. I'll send you a link to that, and you can also download the workbook. Also want to tell you, don't forget, we have a free webinar coming up in a couple of weeks. I'm sorry, I got to edit this a little bit so it looks better. It's about Open RAN architecture with Dr. Marcin Dwarzyński, and he's a PhD working in telecoms. I'm really excited for this. I think Open RAN is fabulous for the business, for telecoms. So join us. That's on the 27th. That's 2 weeks from yesterday, the 27th of February at 5 p.m., same time as this one. And that's on a Saturday. Open RAN architecture. Join us for that. Did you get that? Yeah. There's the link. You can sign up. It's completely free. Saturday, the 27th of February. Any other questions? Let me get back to my workbook. Yeah. Better save that before I lose anything, do anything foolish. Okay, well, thanks so much for joining me. I hope you enjoyed this. I hope it helps your own modeling. If you've got a modeling project or a reporting project that you're doing in Excel, send it to me, or send me a DM me, send me an email, and I'll try to help you with it. I'd love to try and help you with it and see if we can't improve your model and improve your modeling skills as well. All right, thanks so much. That's it for today. I appreciate you joining me. Take care and have today's Valentine's Day. I hope you did something special for that certain person in your life. And thanks a lot for being here with us. Thanks for supporting Cafe Tele. Bye now.